BIM, GIS, and Facilities Management, the Implications of Web Services for the buidlingSMART Alliance, Part 2. If we just look at Google Earth, there's two versions of Google Earth. I'm looking at Google Earth Pro, but even the free version has a lot of these features. For example, you can get weather data. If I turn on weather data, it's going through web services actually and pulling data from many different sources, including this cloud cover data and individual points. Let's say here's a temperature in Long Beach right now. I don't even know where the source of this is, and it doesn't really matter, just pulling it into this particular user interface. And there's a lot of other data as well too if you keep on zooming down into a city level. Let's look around Pasadena a little bit. So within Pasadena, there's demographic, actually for the whole US, actually, they even have demographic data or parcel data in Google Earth Pro. So you click on a parcel here, it pulls it up probably from some information from the county government that shows the parcel number and the value and the address and the square footage, number of baths, etc. So there's a ton of data coming in live into Google Earth just by itself, and even the satellite imagery is obviously coming from Google Earth, from Google itself. The parcel data is coming from some county tax information probably, and there's the weather data again of Pasadena. The point here is that if we think of BIM in this scenario, and if we think of web services and you want to do a mashup from many different sources, it's going to be impossible to get all of these different sources of data all to agree on a common XML standard, for example. Just the fact that they're using a standard format that can be fed into web services allows mashups like this to happen. And so, for example, if I get down to the building level here, there's even 3D buildings coming in from Google. So they have 3D shapes, and some of the buildings even have texture maps on them like this. And so let's look at something else now. So everything I've shown you so far is straight within Google with web services linking to other things that I've already built into these links inside Google Earth. But now I'm going to turn on one more piece here. I'm going to turn on a sensor on this building. So this is just one point. If I click on this point here, it pulls up information about the sensor. So it's actually hitting another server even. So it's hitting the Onuma model server for this interface inside Google Earth. It's hitting the Opto22 sensor coming from a device here sitting inside this building that says here's the current energy use, the true power being used. It's a weekend, so you can see it's kind of low right here. And if you look to the left here, there's other Fridays and Saturdays. You can actually see more information there as well too. The point here again is web services pulling into Google Earth through the Onuma system interface. So there's multiple servers kind of merging together here. And even down here from the Onuma server, the model server, it has information about this piece of equipment. If the information is there, the installation date, for example, May 23rd, power information, etc. What would be great is if we had a link to buidlingSMART Alliance, the SPY data, for example. I could see a day when SPY data is available through web services and can feed out into an interface like this in Google Earth. So this point here, actually what we're looking at is BIM, but all it really is this one point in Google Earth. There's a point there. That's actually a BIM coming from BIM server with data coming from many sources. This data can be feeding to other tools as well. I'm just showing you how it would work in Google Earth with Onuma with Fusion, but imagine another application that could also read this. You don't want to replicate it all over the place. You basically want to see it in the same place. Okay, one more thing here is let's turn on this building here. So these are buildings now in the Pasadena City College campus. These are actually being fed from the Onuma system server. The shapes are, as are the points that show the, let's actually turn on more equipment there. So there's some lights that have been turned on in that room, ceiling lights, etc. Again, with information about that. And these rooms too, if I click on a room, it has information about the room. One other very important point here, I'm actually hitting even another server now. So this name of the room is not even coming, it's coming through the Onuma server, but it's actually hitting the Fusion server that says here's the official name of that room. It's called 226 storage. What else is going on in this room? There's also other data about the room, what floor it's on, how many square feet it is, the condition assessment of the room, the ID, open floor plan. This is actually the ID coming from Fusion. So this is again a mashup coming from many different sources in Google Earth, and I haven't even opened up the Onuma system tool yet. This is just within Google Earth, pulling from the Onuma server data from many sources, merging together, mashing together in Google Earth. And if we extend this out, and you think of other tools connecting to this as well, which we have done with Revit and ArchiCAD and SketchUp, but in this particular view, we're just looking at this in the Google Earth with the buildings on this campus. Webservices really empowers you to manage immense amounts of data. I mean, if we zoom back out in Google Earth, obviously there's tons, millions and millions, if not more, data points that are coming in live into this interface, allowing us to view data from many different angles, from many different scales, and having BIM feed into this system. Imagine this ecosystem with BIM feeding into it, which we have done with the California community colleges. So I just showed you one campus, but we have 5,000 buildings throughout the state of California in BIM, in IFC format, in COBie, with web services using BIM XML that can be accessed by other tools that are capable of pulling that data into their application. And we think that the BuidlingSMART standards and the BuidlingSMART data that's being developed has to move into this type of ecosystem. The world is already has already moved very rapidly into this arena, and we think that BuidlingSMART is perfectly positioned, if we have the will to do so, to enable this data in an environment such as this. This is not only about the Onuma system, this is just about all BIM applications, whether they're desktop or web-based or whatever. There are ways of using this data in multiple formats like this. So now we're in the Onuma system looking at the same building in a web browser. As far as web services goes, on the left side we have a campus full of buildings. You can see the building names and numbers, and on this second floor we have a bunch of rooms, room names and numbers. We're in the Onuma system, but we're hitting the Fusion, the Foundation for California Community Colleges web services for building names and numbers. They have all 5,000 buildings, 120,000 rooms categorized. There's no reason for me to retype them or reinvent them here in the Onuma system. So they're automatically showing up here in my floor plan in BIM. So if I were to export a COBie file from here, from the Onuma system, to export a static file of the current condition of this building, it would go and grab data from the Foundation's server for the building names and numbers, for example, grab the data from the Onuma system for BIM, and create that COBie or IFC output or XML output. If I click on a single room here and I go over to the classification that the Foundation for California Community Colleges uses for top code, this is a room classification system. This pull down has, I don't remember, several hundred types here of different for the state of California. This data actually is, the interface is inside Onuma, but I'm hitting web services just for this pull down controlled by the state. There's no reason for me to manage that because they might be adding new classifications. It doesn't matter to me if they add a new classification. The only thing that's required is that this is kept consistent. So we don't want a classification that says 6760 changing from staff diversity to storage, for example. It's more about keeping consistent. If you have a simple web service like this is an extremely simple web service. It's just a list of classifications, which is very similar to what we would need in BuidlingSMART for OmniClass, for SPIE, for other things. We can start simple like this and just at least get a pull down that's consistent, that can be used across the industry, and then vendors could come and pull it from the source, the authoritative source. In this case, it's the Foundation for California Community College. There was a lot of discussion on BuidlingSMART Alliance phone call the other day about, well, if I'm a software developer and I don't want to have to go on constantly get this live, what if it doesn't work anymore and I can't get to that server, or if it changes? All of that is solvable. For example, if I'm a software developer and I want this pull down, but I want it to be static, I just want to take last year's version, I could store this pull down on my server and then just go update it every once in a while, every week or every year or every minute, or it's really up to me. That server is available, and it's up to me whether I want to pull that data live or I want to pull it and store it on my side, or even archive it and say, here's last year's version and the 2008 version. That is possible as well. It's a very simple from a technology point of view, this is extremely simple to implement. There's nothing magical about this. It's just we need to have the will to say, okay, this is how we go about managing structured data, and starting simple with something like classification systems is the perfect place to start, and I believe that's where Building Smart should start with the standards that we're developing.